In this video, we're going to sketch graphs of polynomial functions, and we're going to be using our graphing calculators for this, so you'll want to have them ready. But before we do that, we're going to talk about what it takes to analyze a function. So you'll want to write this down on your notes somewhere so you don't miss any of these pieces to analyzing a function. And there are four main pieces, and a lot of times we'll split it up into different quadrants. One piece is domain and range. Okay? You need to give the domain and range. That's one piece of analyzing a function. Another piece is relative mins and maxes. Okay. Just listing those points where we have a relative minimum or a relative maximum. Relative minimums look like this on a graph. So that bottom point, relative maximums look like this on a graph. So that peak, that high point. So those are some of the things we look at for relative mins and relative maxes. Another thing that we list is end behavior. And that's, from the previous examples, that is increasing without bound or decreasing without bound. What is it doing on the left end, and what is it doing on the right end? And lastly, the fourth piece to analyzing a function is the intervals where it is increasing. Where is the function going up as we go to the right? And where is the function decreasing? Where is that function going down as we go to the right? All right, so we're going to look at four different graphs here. We're going to use the graphs, use our calculators to graph them, and then we're going to analyze them using those four, talking about those four different aspects of the graph. So the first one we're going to do is y equals 1/2 x cubed. So I'm going to pull up our calculator. I'm going to go to y equals. And since I have an equation in y sub 1, I'm going to get rid of that. And my plot is turned off. Make sure your plot's turned off, because sometimes that can cause issues with your graphing. So I'm just going to enter 1/2 x cubed. So I have 1/2 x, and then there's the exponent button. Use this little caret button right here. So 1/2 x cubed, and I'm going to graph that on the standard window, zoom 6. And that's what it looks like. So our y and x intercepts are both 0 in this case. So I'm going to go back and I'm going to sketch this graph. And it looks something like this. And then I'm going to analyze this function with those four pieces. First, domain is negative infinity to infinity. Remember, domain goes left to right. Range goes bottom to top, so that is also negative infinity to infinity. And on this one, there are no relative mins and maxes. There are no peaks or valleys. There are no, so we can write that down, no relative mins or maxes. Third, the end behavior. So the end behavior, what is this doing at the left end? Well, at the left end, this is going down forever and ever and ever. So So we say that on the left end it is decreasing without bound. And then on the right end, it is going up and up and up and up. So we say it is increasing without bound. And the last kind of new thing that you haven't really done before is where is it increasing and where is it decreasing? Well, as we go from left to right, this graph is increasing everywhere. It's going up as we go to the right everywhere. So then it is increasing on the interval negative infinity to infinity. It is increasing everywhere because it's going up as we go to the right everywhere on this graph. Now, the next three examples are going to be a little bit different. We are going to have relative mins and maxes, and we are also going to have places where they will increase and decrease. So, here is the next one. So we will sketch the graph first. So we will pull up the calculator, go back to y equals, clear out what we have, and we're going to put in 3x minus x cubed. And we'll graph that on the standard window, Zoom 6, just to take a look at it. We may need to, and we don't. So we're good. We see mins and maxes. We see everything we need to. Now, what we're going to do is use the calculator to find all those key points we need to. And I always work from left to right. So the first key point we come to as we go from left to right is a 0. It's an x-intercept. So I'm going to calculate. First thing I will do is just sketch this graph quickly. I'll go back here. And it comes down. And that's what the graph looks like. And I have 1, 2, 3, 4, 5 key points that I'm going to label on this graph. And I go from left to right when I calculate those using the calculator. And if I give any decimals for these, I'm just going to round those to the nearest 100. That's all I'm going to do. First one I come to is an x-intercept. So, going back here, I'm going to calculate, I need to hit second harder, I'm going to calculate a 0. Okay. So, and I'm just going to work from left to right. It works pretty efficiently. Left bound. And I'm going to right arrow until I'm to the right of that. And to calculate that, so my first x-intercept is the point about negative 1.73. So I'm going to go back to my graph, and that's negative 1.730. That's that first x-intercept. Now, my next key point that I come to on this graph is a relative minimum, is a bottoming out point. It's not a minimum on the whole graph, because I have points over here that are smaller, that are lower on the ground than this one, but it's lower than any point right around that point, so we call that a relative minimum. It's minimum relative to all the points around it. So I'm going to go back to my calculator. Now I'm going to calculate a minimum. Number 3, and again it's going to ask me for a left bound. I'm to the left of that. And then it's going to ask me for a right bound. To the right of that. And sure, that's my guess. So my relative minimum is the point negative 1, negative 2. So I'm going to go back to my graph, and that point is the point -1, -2. Now, this looks like it's a point 0, 0. We can confirm that by calculating another 0 there. So I'm going to calculate a 0, and I'm to the left of that. And I'm going to right arrow until I'm to the right of that 0, right about there. And it is in fact 0, 0. My next point of interest is the maximum. So I'm going to go back to my calculator and I'm going to calculate that maximum. So I'm calculating a maximum. Left bound, yes. Now I'm to the right of that. And that's going to be the point 1, 2. Again, 0.9999998, very close to 1. So this max is the point 1, 2. And finally, my last point of interest is another x-intercept. So I'm going to calculate another 0. I am to the left of that. And then I right arrow until I'm to the right of that. And my last 0 is 1.73. That's my last x-intercept. So I've labeled all the key points on the graph. So now we are ready to analyze this function. So we will do that over here. First piece for analyzing is domain and range. The domain goes from left to right. The domain is negative infinity to infinity. The range, bottom to top, is also negative infinity to infinity. So we have the domain and range. The next one, relative min and relative max. We have one of each. And all you do is give the coordinates of each of those. The relative minimum occurs at the point -1, -2. And the relative max occurs at the point 1, 2. And the next one, end behavior on the left end. The left end is going up. It's going up and up and up and up and up. So on the left end, it is increasing without bound. And the right end, it's going down and down and down and down and down. So that is decreasing without bound. That's the end behavior. So the last thing is, on what intervals is it increasing and decreasing on? Okay. Now, with increasing and decreasing, we always work with our intervals from left to right, and we look at the x coordinates. I will make a note back here. When increasing and decreasing, x coordinates. Always deal with the x coordinates when working with increasing and decreasing, and we always go from left to right. Now, an increasing piece of the function is one that goes up as we go to the right. So where is this graph going up as we go to the right? It's going up from here to here. So it is increasing on the interval from -1 to 1. And the reason we use parentheses and not brackets for these increasing and decreasing intervals is because right at -1, this graph is neither increasing nor decreasing. It is a minimum. Same nor decreasing. So it is increasing on the interval from -1 to 1. And then finally, decreasing. It's decreasing from here to here. It's going down as we go to the right. So it's decreasing on -infinity to -1. Union, now the reason we use that union symbol is because it's decreasing 2 places. From here to here. It's also decreasing from here to here. So it's decreasing on 2 intervals. This interval, the left end of it is 1. The right end of it is positive infinity. So on these increasing and decreasing intervals, you should have, on these polynomial functions, everything from -infinity to infinity taken care of, except for the points where we have relative mins and relative maxes. And we do. We've got -infinity to -1, we've got -1 to 1, and we've got 1 to infinity. So everything from -infinity to infinity is taken care of on these increasing and decreasing intervals. And again, remember, we are dealing with the x coordinates. Now, with the next graph, and I will quickly sketch the x and y axis. So it is -x cubed plus 2x squared minus x minus 2. I will try to remember that as I enter it onto my calculator. So I will go to y equals. Here we go. And we have -x cubed, and again, to get out of that exponent, do right arrow, plus 2x squared minus x minus 2. Just to take a quick look, make sure I got that correct, and I do. So we're going to once again grab that on the standard window, zoom 6, and we're going to take a look and see what we have. And that's what we have. So I'm not 100% sure what's happening here. We'll have to take a closer look at this. Now, so we're going to work from left to right and find these key points, these points of interest. Now, the first one we come to is the x-intercept. So I'm going to calculate that. We calculate, and again, the calculator calls it a 0. We're to the left, and then we're to the right. And so that's at the point about -0.70 when we round to the nearest hundred. So our first point of interest, and I'll put that out here, is -0.700. Okay, so that's that first point of interest. Now, the next one looks like it's going to be this y-intercept. Again, we can find that by tracing and put in x equals 0, enter, and that is -2. And some of you might have thought, well, that's no coincidence. It's a constant in. So we'll go 0, -2. Now, what may happen here is it kind of looks to me like there may be a minimum just to the right of that y-intercept. So we're going to see if we can calculate that minimum, which is number 3. I think we're to the left of that. Then it looks like we're to the right. So our guess, and in fact, there is a minimum just to the right, and it's 0.33 right about there. So I'm going to calculate that maximum. And the maximum is at 1, -2. So that's going to be straight across from the y-intercept. So that's the point 1, -2. And that is our last point of interest. There are no other x or y intercepts, no other mins or maxes. So I'm just going to sketch it in this graph. So we've got all those points labeled. Now we're ready to analyze this function with those 4 pieces. The first piece is domain and range. Domain from left to right is -infinity to infinity. And the range from bottom to top is -infinity to infinity. And then relative mins, relative maxes. We have a relative minimum, one of those, at this point. So 0.33, -2.15. And we also have a relative max at the point 1, -2. Then the next step is the end behavior. The left end is going up and up and up and up and up and up and up on the left end. So we say it is increasing without bound. And on the right end, it's going down and down and down and down and down. So we say it is decreasing without bounds. And finally, for the analyzing the function, where is it increasing and where is it decreasing? And again, as we go from left to right, that is huge. So the only increasing piece is from here to here. So it is increasing on the interval 0.33 to 1. And again, just a quick reminder, when giving the intervals on which it is increasing and decreasing, use the x-coordinates. And just like the last one, we are decreasing on 2 intervals. We are decreasing from here to here. So we are decreasing on -infinity to 0.33 union, and from here to the end, 1 to positive infinity. So we are increasing on the interval 0.33 to 1, and decreasing on -infinity to 0.33, and also on 1 to infinity. So that is graphing and analyzing these functions. And we've got one more that we will graph in this case. I'm guessing that 10th page is a blank page. Might be left over from before. Now, so in this case, this is the last graph we are going to do. So we have 4x to the 4th plus 6x cubed minus x. So back to our calculator. Clear out the equation we have in y equals. So we have 4x to the 4th. And again, right arrow to get out of that exponent, plus 6x cubed, right arrow, and a quick glance to see what that last term was. It is minus x. So we finish it with a minus x. And once again, we're going to graph it on the standard window just to take a look at this. Okay, so there's a lot going on there. And it looks like we're going to have some mins and maxes, and so on. So I'm going to start calculating key points from left to right. That way we're not missing any. And this first one is an x-intercept, so I'm going to calculate that first x-intercept. And as we go along, I'm going to put those on the graph on the flip chart. So calculating that first one, we've got negative 1.370, so that is our first key point. So I'll put that over here. We've got negative 1.370. And these can get a little bit crowded. Back to the graph, our next key point is this minimum. So I'm going to calculate that minimum to the left, and then again to the right. And it's negative 1.07, negative 1.04. So that is the minimum. Well, we'll put that right about here. Negative 1.07, negative 1.04. Back to the graph. Looks like we have an x-intercept there to calculate. So we're going to calculate that x-intercept. To the left, to the right, stand up, sit down, fight, fight, fight. And that second zero is at negative 0.50. So we'll go about there. So this is what we've got going on here. Comes down here, we have a relative minimum there, crosses again, and it's going to have another relative maximum here. And based on our equation, we should be able to see that that y-intercept is the point 0, 0. And this x-intercept is negative 0.50. That's the point 0, 0. We're going to have another maximum that we're going to calculate. So back on the graph, we're going to calculate a maximum. We are to the left of that, and to the right. So negative 0.27, 0.17. So this maximum is negative 0.27, 0.17. So that is that maximum. Back to the graph. We're going to have another little minimum there. So we're going to calculate that next minimum. Start to the left, start to the right, and we're at 0.22, negative 1.15. 0.22, negative 0.15. And finally, we have one more zero to calculate. And that's at 0.37. Now, phew, it's a lot of points to graph. Now we're going to analyze this function. So now to analyze this function, first it's domain and range. The domain, left to right, negative infinity to infinity, and the range from bottom to top, and again, on with the y coordinates, the bottom point is negative 1.04 with a bracket, top is infinity. So, we have two relative minimums, here and here, so we're going to list those both. So the relative mins, one point is negative 1.07, negative 1.04, and the other one is 0.22, negative 0.15. Those are the relative mins, and we have one relative max, and that is this point right here, negative 0.27 and 0.17. Those are the relative mins and maxes. Next piece for analyzing the function is the end behavior. So on the left end, it is going up and up and up and up, so we say it is increasing without bound. And on the right end, it is also going up and up and up and up. So we also say it is increasing without bound. And finally, where is it increasing and where is it decreasing? Now with this one, we're going to have two intervals for each one because it is increasing on two different intervals and decreasing on two different intervals. And again, increasing means we're going up as we go from left to right. So it is increasing on this interval here, going up as we go to the right. And again, with increasing and decreasing, we focus on the x-coordinates. So it is increasing from negative 1.07 to negative 0.27 union, and it is increasing from here all the way to the right. So it's also increasing on 0.22 to infinity. And then, where is it decreasing? Decreasing is going down as we go to the right, so it's decreasing on this interval from negative infinity to negative 1.07. And it's also decreasing from here to here, from negative 0.27 to 0.22. Phew! That was a lot. A lot goes into graphing and analyzing those functions. But using our graphing calculators to find those points of interest and then just taking a look at the graph to analyze those four pieces. So make sure you get those four things down on your worksheet somewhere just to remind yourself what you need to include to analyze these functions. And that is graphing these polynomial functions.